Hello, my dear students. Hope you're all doing great. I missed you so much. So let's start our session of science for today. This is chapter 9, comparing kinds of matter. Today we will start lesson 1, properties of matter. This is page 480 in your textbook. How can you describe matter? Pretend you have lost your backpack. You want to describe your backpack to your friends so they can help you look for it. How could you describe it so that they know which one is yours? You can say how large the backpack is or how many things there are inside. You could talk about its color, texture, or even the hardness. In each case, you are describing a property of your backpack. So what is the meaning of the word property itself? The word property, a property is something that can be observed about an object or a group of objects. Properties of matter can describe the amount of matter or what the matter is like. This is the properties, like the characteristics. The first property of any matter is mass. One way to describe the backpack would be its mass. Mass is the amount of matter in an object. So the amount of matter in an object is called mass. Mass compares the amount of matter in a sample to standard amounts. Standard means fixed. When I need to compare something, I need a reference. I need something that is fixed or constant to compare with. Mass can be measured on an equal pan balance. This is the equal pan balance. Most of you might have seen it in the grocery shop. This is a balance with two pans. This is called an equal pan balance. This is used to measure mass. Gravity pulls on the standard pieces and on the sample. Yes, it pulls both the sides or both the pans of the balance. In this case, when the balance levels out means becomes stable. The amount of matter in the sample and the standard pieces must be the same. Mass is measured in kilograms or grams. Yes, this is the mass of an object measured in kilograms or grams. 1 kilogram is equal to 1000 grams. This is so important. 1 kilogram is equal to 1000 grams. Adding up the grams of mass in the standard pieces gives the mass of the sample in grams. The mass of an object is always equal to the sum of masses of the pieces of the object, like your backpack. The mass of the backpack as a whole equals the mass of all the books inside your backpack. The second property is the weight. Try holding a marble in one hand, you know, the small marbles, and a basketball in the other hand. They feel different for sure, yes. It is harder to hold up the basketball. You are feeling the weight of each ball. Yes, the weight is how strongly gravity pulls on an object. Weight is how strongly gravity pulls on an object. If an object has more mass, so it will also have more weight. Weight is measured in Newton. We said that mass is measured in kilograms or grams, don't forget. So weight is measured in Newton. 1 Newton is equal to 0.225 pounds. This is LBS, this is in the English system. So 1 Newton is equal to 0.225 pounds. Okay, gravity is greater on planets with more mass. Do you remember when we said that if the object has more mass, so it will also have more weight? So what about gravity? Gravity is greater on planets with more mass. So an object's weight depends on the planet it is on. Yes, if the planet is greater, it will have more mass, meaning the object will have more weight. But an object's mass is the same on different planets. Suppose that your mass here is 100 kilograms, but your mass on the moon still 100 kilograms. What about your weight here? Your weight here is about 50 newtons, but your weight on the moon will be different because the moon is smaller than the earth, so it has little mass or less mass than the earth. Okay, then let's move to the third property of matter, which is volume. Volume means the size. Mass and weight describe the amount of matter in an object. Mass and weight describe the amount of matter in an object, but what about the size? Volume, volume measures how much space matter takes up. Volume measures how much space matter takes up. Like this one, a marble's volume makes the water level rise when you place it in a graduated cylinder. This is named a graduated cylinder containing 40 milliliters of water. When you put this marble inside the graduated cylinder with water, the water level will rise up from 40 to your left to 50 to your right. Okay, so a marble's volume makes the water level rise when you place it in a graduated cylinder. Matter in the marble makes up space. Yes, it takes up space and to push water out of the way. Yes, it pushed the water out of the way by this 10 millimeters. Okay, the change in the water level when an object is placed underwater tells us the object's volume. Yes, I can know the volume of any object when I put it under a certain amount of water because it pushes the water. Volumes of liquid are often measured in milliliters, which is abbreviated as ml, by using a graduated cylinder like this one to your left, to your right, I'm sorry, or a beaker. This is named the beaker, the one in the middle, and the one to your right, to your left, this is measuring cup. So volumes of liquid are often measured in milliliters. This is the unit of measuring liquids. But the tools used to measure liquid are this one, the graduated cylinder, or a beaker, or a measuring cup. Okay. The volume of solids is usually measured in cubic centimeters. Cubic centimeter is abbreviated as cm with 3 on top of it. So a volume of 1 cubic centimeter equals 1 milliliter. So what about matter? Now we have studied the properties of matter. Let's see what is matter. Now that you understand the mass and volume, we can use the best definition for matter. Matter is anything that has mass and volume. Matter is anything that has mass and volume. That is a broad definition. Almost everything in the world around you is matter. Yes, this is a fact. What is density? Now we will talk about a different property named density. Think of a large empty box with a lid which is a cover. The box has a large volume and a little mass. It has large volume, large space inside, but it is not heavy. It is lightweight. It has a little mass. If you place a few marbles in the box, it has more mass. You are increasing the mass, but the same volume. Yes, the box did not expand. Add more marbles and there is more mass, but the volume stays the same. As you add more marbles, you are increasing the box's density. So what is density? Density is the amount of mass for each cubic centimeter or milliliter of a substance. Density is the amount of mass for each cubic centimeter or milliliter of a substance. So how to calculate the density? To calculate a sample's density, you divide its mass by its volume. So if I need to calculate the density equals mass divided by volume. Okay, a marble and a rubber ball, for example, can be about the same size. Okay, which one do you think is denser, the marble or the rubber ball? Yes, if you thought about the marble, it will be a less dense. The marble has more particles or more mass inside of it than the rubber ball, the marble. So I'm sorry, in this part, let's repeat it again. If you have a marble and a rubber ball that can be about the same size, okay, you have two balls, one of them is made of marble and the other is made of rubber. They are of the same size. Which one is denser? Yes, for sure, the marble is denser than the rubber ball. The marble has more particles or more mass inside of it than the rubber ball. So in this case, the rubber ball has air inside. Air is less dense than both the glass, which the marble is made of, or the rubber, which the rubber ball is made of. Those observations tell you that the marble is denser than the ball, the rubber ball. With boxes and other containers, you can change density by adding more mass inside. With boxes and other containers, you can change density by adding more mass inside. How? You can also change the density by changing the volume. As we said, density is calculated by dividing the mass over the volume. So if you increase the mass, so the density will increase. If you decrease the volume, also the density will increase. You could stretch, crush, or bend the container to let air in and out. In this case, you will change the density. Most matter, however, acts like the marble. Do you remember the marble? You cannot add more mass to the inside, nor you can stretch it. Yes, it is hard, it is solid. You cannot do anything in it. Its density will always be the same. Like this one, this is the rubber ball on top. This is floating on the surface of the water, while the marble, it sinks inside the water because it has more mass, which means more density. Okay, then let's talk about floating and sinking. When an object is placed in a liquid, gravity pulls the object down. This is for sure. If any object is placed in a liquid like water or anything, gravity pulls the object down. Okay, in order for the object to go down, the liquid must move out of the way. It must move in other directions to let this object sink in the water. What would happen if the liquid was denser than the object, like the rubber ball? In this case, the water was denser than the rubber ball. It didn't get out of the way. The water didn't get out of the way. In this case, the object, like the rubber ball, it would not sink. It would float. Excellent. Then objects can float as a result of buoyancy. This is a new word, a strange word. This is named buoyancy. Buoyancy. What is buoyancy? Buoyancy is the resistance of sinking. The resistance of sinking. Resistance like blocking, like not getting in the way, like standing. So buoyancy is the resistance of sinking. Buoyancy takes place because the liquid that is being pushed out of the way pushed back on the object. Buoyancy, which is the resistance of sinking, happens because the liquid that is being pushed out of the way pushes back on the object that pushed it. If an object is denser than the liquid, like the marble ball, if an object is denser than the liquid, then the object can push harder the liquid and it will sink. If the liquid is denser than the object, then the liquid can push harder and the object floats. Yes. So in this case, this is what would happen. Buoyancy also depends on the shape. Like what? Look at these two pictures. This is aluminum blocks, and this is aluminum canoe. This is like a small boat. So both of them are made of the same substance, which is aluminum. Okay, but the aluminum blocks will sink once they get into the water, while the aluminum canoe will float. Why? Let's see. Buoyancy also depends on the shape of the substance. A block of aluminum like this one will sink, but an aluminum canoe will float. Why? The canoe's shape holds in air, so that it acts like it has less density than the water. But if the canoe is full of water, for sure it will sink. Okay. Many liquids also have a property called the surface tension. Surface tension. In water, every particle pulls toward the other particles. In water, every particle pulls toward the other particles. So the attraction between all the particles of water forms a skin on the surface of the water. This skin is what surface tension means. Can you see this mosquito here? It looks like it is standing on the top of the water. It stands on the skin on the surface of the water. Like this spider also, look, it's not swimming, it is walking on the surface of the water. If an object is spread over the surface, it can rest on this skin, even if it would not normally float. So in the normal state, this spider will sink in the water, but if it is spread over the surface, it can rest on the skin, even if it would not normally float. If an object is not spread out enough, it will break the skin and sink in the water. Okay, then let's talk about the states of matter. We all know that we have three states of matter: solid, liquid, and gas. A state of matter is one of the three common forms that matter can take: solid, liquid, or gas. So let's talk about all of them. You interact with these states of matter every day. The desks and books, they are solids. The water that you drink is a liquid. The air you breathe is made of gases. Each state has its own properties, so let's study solids, liquid, and gases. Let's start by solids. The particles in a solid have very little freedom to move. As you can see, the particles, they are arranged beside each other, they are stuck to each other, but the particles vibrate in their place. A solid stays in a definite shape with a definite volume. Definite means fixed, stable shape and volume, no matter what container it is in. For example, the disk. Your disk at your school, the disk is, it has definite shape and a definite volume, whether it is in the class or it is in the factory or even on the cars that are transporting them. So it has the same shape and volume. This is for solids. Okay, a rock is a solid, yes. The shape and the volume will not change unless something changes it, such as breaking or heating it. Many solids, such as table salt, the one that you can see in the picture, this is the salt that we add to our food, is called the table salt, have regular shapes like cubes. As you can see, these are the cubes of table salt. In general, a solid is the densest state of matter. This is the densest state of matter, means it has the most density. Okay, then let's move about liquids. In a liquid, the particles move freely than in a solid. In a liquid, the particles move freely than in a solid. As you can see, they can move. The particles are close together, but they can flow past each other. They can move, flow past each other. This flowing allows a liquid to take the shape of its container. This flowing allows the liquid to take the shape of its container. Yes, I have some water. I can put them in a cup of water or in a glass of water or in a huge container. It will take the shape of its container. Liquids have a definite volume. Yes, they have a definite volume, but not a definite shape, because I can put them in many different shapes. In general, a liquid is the second densest state of matter. A liquid is the second densest state of matter. So what is the first or the densest state of matter? It was solid. Excellent. Water, however, is denser as a liquid than as a solid. Do you mean the solid water has less density than the liquid water? Yes, for sure. And during summer, when you have your juice or even the water that you need to make it cooler, so you put some ice cubes inside. Have you noticed that the ice cubes float on the surface of the water? Do you remember floating and buoyancy? So why the ice floats? Because it has less density than the water, like these ones in the ocean. Okay, then let's move to the last state of matter, which is gas. Gas particles are not close together. As you can see, they are away from each other, and they can move past each other very easily. This is so easy for the particles of gas. A gas has no definite volume or shape. A gas has no definite volume or shape. It takes the shape of its container. At room temperature, gases move around to fill their container. At room temperature, gases move around to fill their container. Okay, If the volume of the container increases, the gas expands, becomes larger to fill it. This property allows the gases to inflate things. Inflate means come inside things such as balls and the tires. The ball contains water. Also the tires, this one, when the air is increased inside or supplied, so it becomes like this one. In general, a gas is the least dense state of matter. So arranging matter according to density, solids is the densest, solids are the densest state of matter, then liquids, and the least dense state of matter is gases. Here, as you can see from this picture, the air is a gas, but solids like rocks, and this is the arrangement of the particles, and the liquid, this is the water. Thank you for today. See you in the next episode. I hope you have enjoyed this one and understood the lesson. See you in the next one. Thank you and goodbye.